Hi everybody. So in this video, we're going to look at the expressions with roots of polynomials for this quartic equation. We've been told its roots are alpha, beta, gamma, and delta. We've been asked to find the expression alpha squared plus beta squared plus gamma squared plus delta squared. So the first thing we need to do is we need to think about the sum of the individual roots, and we call this the sum of alpha. So this would be alpha plus beta plus gamma plus delta, but we write it like this. We also need to remember that the coefficients follow a pattern of being negative, positive, negative, and positive. So to work out the sum of individual roots, we're looking at this term. And because it's already a negative, this means it'll be equal to positive 2. Then if we look at the sum of the product of two roots, which we call alpha beta, we'll find this using this term. Because it's a positive negative 9, this will be minus 9. And then the sum of a product of three roots, alpha, beta, gamma. This will involve this 2 term, but it's a negative 2. And finally, the product of all four roots, alpha, beta, gamma, delta. This will involve this 8 term, and it's a positive 8, so this will be simply 8. So now what we need to do is to work out this expression using a combination of these four values. And the only way of getting this expression is if we work out alpha plus beta plus gamma plus delta all squared. So if we have this multiplied by itself, we have the alpha squared, alpha beta, alpha gamma, and alpha delta. And then we can move on to the beta term, where we get beta alpha, beta squared, beta gamma, and beta delta. Then we'll look at the gamma term. We'll get gamma alpha, gamma beta, gamma squared, and gamma delta. And then finally, the delta term, we'll have delta alpha, delta beta, delta gamma, and delta squared. So now we can highlight the product of two roots. And what we find is we've got two lots of a sum of a product of two roots. So you can see we've got alpha beta here and here, alpha gamma here, and each of them would match up. So we can write this as alpha plus beta plus gamma plus delta all squared is equal to 2 lots of the sum of the products of two roots. And then we can look at what terms are left, and we've got the alpha squared, beta squared, gamma squared, and the delta squared. And this is exactly what we were asked to find. We know the sum of the individual roots is positive 2, so we'll have 2 squared is equal to 2 times the sum of the product of two roots, so negative 9, plus alpha squared, beta squared, gamma squared, and delta squared. So now all we need to do is move this negative 18 to the left-hand side. So this will become the 4 plus the 18. This will be 22. Okay.